All right, this is chapter 8-6, proportions and similar triangles. Please copy your cuts. All right, looking carefully at this, we're looking at theorem 8-4. Remember, it's more important that we look at the theorem name opposed to the number. This is Triangle Proportionality Theorem. If a line parallel to one side of a triangle intersects the other two sides and it divides the two sides proportionally, what does that mean? And of course my board doesn't want to cooperate with me right now. Alright, so we have the following two triangles. We have triangle QRS and TRU. And what the triangle proportionality theorem is simply stating is if a line is parallel to one side of a triangle and intersects the other two sides and it divides the two sides proportionally, what does that mean? So basically, TU is a proportional line. It is in direct proportionality or parallel, to QS. So TU is parallel to QS. And because the line segment TU is parallel to QS, that means I will have two similar triangles. That's going to look like, first of all, if I look at the small and large, if this were my larger triangle here, I'm saying that it's going to be proportional to the smaller triangle, which I'm saying is this one here. These two will have proportional segments. This small side, RT or RT, will be exactly proportional to this smaller section, TQ, or I can say also RQ. Alright, what does that look like? Well, if I write it out, and the screen just wants to jump all the way around. If I write it all the way out, I'm going to come back over to the computer. If I have segment TU is parallel to QS, then that automatically means that line segment RT is going to be directly proportional to TQ. I'll say that again. If we know that TU is parallel to QS, then that automatically means that segment RT on this smaller triangle, RT is directly proportional to TQ. Likewise, RU on the bottom portion here on the smaller triangle is going to be directly proportional to US. There's another way we could also write this here. I could also write this as, and let's delete this, undo. I can also write this as what? What is RT also proportional to? I can look at the full length. So I could also write RT is proportional to RQ. So I can do the full length. What else does that mean? That means that RU is proportional to what? The full length RS. Okay, I can also say and make another proportional ratio and say that TQ is proportional to RQ. And what else? US is proportional to RS. These are just some other proportions you could also state. Well, here's the main one. RT is proportional directly to the TQ, and then RU is proportional to the US. Okay, moving further. And I already took the triangles apart for similarity. Looking at the next section here. (8-5) is the converse. Hopefully you remember the word converse means the opposites. The opposite of triangle proportionality theorem is if a line divides two segments of a triangle proportion, then it is parallel to the third side. So what is that going to look like? This time I'm saying first, if segment RT is proportional to TQ, and if RU is proportional to US, then that's going to mean that TU is parallel to QS. So on the first part, on 8-4, what I was saying first is, I was saying that the two lines is parallel, and if the two lines are parallel, then that means that the two segments, two pair segments, were going to be proportional. On 8-5, I'm saying the opposite. First, now I'm saying if the two segments are proportional, RT to TU, and then RU to US, if that's true, now I'm saying the opposite, that the two lines will be parallel. So let's look back quickly. So on the first one, I said that the two lines were parallel first, TU to QS. Then that meant that the two segment pairs were proportional. The converse, again, is opposite. That means these are going to be switched. The parallel part is going to be in the back, and the two proportional statements will be up front. So here it is. Now I'm saying that if the two segments are proportional, two segment pairs are proportional, then the two line segments TU and QS will be parallel. Okay? Now next, Theorem 8.6 deals with parallel lines. If I have three parallel lines that intersect and two transversals, then they're going to divide the transversals proportionally. What does that mean? Okay. What are the three parallel lines that I see? First of all, the first parallel line I see is UV, or line R. That's one parallel line. It's parallel to line WX, or line S. And then finally, the third line is YZ, or line T, in other words. So if I have three lines, and I'm told that they are all three parallel to one another, and if those three lines are going to be intersecting two transversals, they're going to have proportional ratios. So that means that if I know that line R is parallel to S, R is parallel to S, and S is parallel to T, and you should know from transitive property that means if R is parallel to S and S is to T, that automatically means that T is parallel to R. Okay? So if I know all three lines are parallel, then that automatically means that UW is going to be proportional to WY. And then also VX will be proportional to XZ. So I did the longer side, I did long over the short, and then long over the short. Or the top over the body. I'll do top over bottom. That'd probably be easier. Alright, so I did, long over the short. I'll stay long short. Okay, so the two long pieces, UW over, and let me back up, the short piece here on the same line, which is line L. So UW here compared to the shorter piece, WY, equal to, on the bottom row now, the long piece first, because I did the long piece in the top first, and I did the long piece in the bottom first, which is VX compared to XZ on the short. Okay? Directly proportional. Okay? So if UV is proportional to WX, and I know to go from UV to WX is 10 to 5, if I ask you or tell you that VX is 6, or 10, I'll do 12, rather 12, I like that better. If I tell you that VX is 12, the question is, what is XZ going to be? And the answer should be 6. Okay? Divide by 2 here, divide by 2 there. Okay? Theorem 8-7 is talking about array. And if array bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So here we have triangle ABC. I know that angle C is bisected because I see I have two congruent angle measures. Angle ACD is congruent to BCD. And when I do that on a triangle, when I bisect an angle on a triangle, that automatically means that the opposite side lengths are going to be proportional. AD is proportional to BD. And this is how I write it. So I have ray CD bisects this angle ACB. Then that means that AD is exactly proportional to DB. The other segment that will also be true is that CA, this segment here, CA, is going to be proportional to CB. So you'll get two proportionally statements. The opposite side, AB, is going to be proportional, and then their leg here, CA and CB, will be proportional. Okay? And then finally, proof will be on the test. You have to remember how to set up a proof. And here we're given this following information. Suppose I'm given this particular shaped object here, and I'm going to erase that just a little bit. If I'm given this information here, where I have ABCD is a trapezoid, we need to first of all remember what's a trapezoid, and we're told that the base is AD, and bases are AD and BC. And if we know what bases are, that means that the two bases are automatically parallel on a trapezoid. So AD will be parallel to CD. Right? I have to prove that triangle EAD is similar to EBC. And the question, remember when we do theorems, on the theorem, on a proof, we always ask ourselves, first of all, what's the first thing we do? We draw a diagram, which is done for us. Step 2, we mark it up, everything we remember. Well, I've already marked up that this is ABCD is a trapezoid with the bases AD and CB. So I marked up to show that AD is parallel to BC. Okay? Then our third thing I do is start thinking about, what kind of things can prove that? Well, two things that I think about, because I know that these two are parallel, I see some I see corresponding angles. I could use corresponding angles. And I know corresponding angles are congruent. I'm also thinking about that theorem we just learned with 8-4, and I'm going to flip back to it. Remember what it said, if you had two parallel lines, then that means that the side ED is going to be proportional to DC, and then EA will be proportional to AB. So we got two different things. I see corresponding angles, and then I see that theorem 8-4. And I'm going to flip back to 8-4 so you can look at it again, because that one looks kind of nice. This one right here. I know it's 8-4 because, and not 8-5, because 8-4 says if you have two parallel lines, and here it is, if you have two parallel lines, then that's automatically going to mean that the two segment pairs will be proportional to one another. Okay, and then 8-5 is the opposite. Remember on 8-5 it said that the two segments had to be proportional. We don't know on our theorem if the segments are proportional. We know that the two line segments back here are actually parallel. So I have to use 8-4 instead of the 8-5 one. And going back to our proof here, when I'm looking at this particular proof, if I'm looking at corresponding angles, I start saying to myself, okay, well, what do I see? First thing I see here, if this is DA, and I'm going to straighten that out just a bit. If I see this is DA or AD, and this is the CB, I see some transversal lines. That means that this will be the CD. Okay? And what do I see? On parallel lines, I know that this angle and that angle, which is here and here, are corresponding. Corresponding angles are what? Congruent. I see one more transversal down here. Okay? And this is your angle A and your angle B. And these two are also corresponding angles. And corresponding angles are what? Congruent. So far I've matched up two pair of congruent angles on two different triangles. So angles D and C are congruent on two different triangles, and then angles A and B are congruent on the two triangles. Why did I do that? I'm going to show you quickly, because there's more than one way to set a proof up. And these are just quick review information on how to set up the proof. The first thing that I did when I was writing up the proof, AD and BC are bases of a trapezoid, ABCD. How do I know? That information was given at the tippy top. Number two, this is also what I wrote. I wrote that AD is parallel to BC. Back here, AD and BC are parallel. Okay, that's the definition of trapezoid bases. That was back in a few chapters ago. So if I know that, I can write that in. Next item that I wrote in. I wrote angle A was congruent to angle B because corresponding angles postulate. Okay, angles B and A are congruent, corresponding angles. And then I also wrote, of course, angles C and D are congruent by corresponding angles postulate. And what do I know? I immediately thought of, if I know two angles on a triangle are congruent, what does that mean? That means that they're automatically going to be what? Similar. So, because I have two pairs, this is my first pair of congruent angles, here's my second pair of congruent angles, that sounds like the angle-angle theorem. So that automatically means that triangle EAD is similar to triangle EBC. Triangle EAD is similar to triangle EBC, again by angle-angle. So that's one way to prove that these two triangles are congruent. Again, it's a proof, so that means you can do more than one way. I also saw theorem 8.4 on this one, or you might have seen theorem 8.4, I should say. Okay, what's the first thing I see? I see ED. I see ED is proportional to DC. What do you mean? I see ED is going to be proportional to DC. How do I know that? That's theorem 8-4. And I also know that EA is proportional to AB. Theorem 8.4. Okay, but the first things I still did this. Even if I had done theorem 8.4, I would have done 1 and 2. So 1 and 2 would have still been the same. I still would have needed this given information, even if I saw theorem 8.4. And I would have needed this second one, AD is parallel to BC, definition of trapezoid, because that information was still given. And then I would have jumped down here for number 3 if I was using theorem 8.4. Okay, which says ED is proportional to DC, and then EA is proportional to AB. Theorem 8.4, the triangle similarity proportionality ratio. And then triangle EAD is similar to triangle EBC by theorem 8.4. All right, and that is 8-6.